Hi everyone, welcome to lesson 2 of the Advanced Higher Stats course. This lesson will cover the skill called working with theoretical and experimental probabilities. This skill is on page 19 of the 2023 course spec. By the end of this lesson, you should be able to use and understand notation for probability theory. You should be able to calculate probabilities of single and multiple events happening. You should be able to calculate the probability of an event not happening. The areas which are crossed out will be covered in the next lesson. Let's start off with a single and simple event, flipping a coin. There are only two possible outcomes, heads or tails, and both have an equal chance of happening. So, if you wanted to write the probability of heads, you would put P, probability of H, which means heads, or you could write heads there as well. And then you would equal, not 50%, but 0.5. In stats, you don't write probability in percentage, you'd write it in decimals. Similarly, if you want to write a probability of tails, you do P, T, or tails equals 0.5. One way you could show the coin flipping event is with a tree diagram. So how this would work is you have the coin flip and then you have two possible outcomes, heads or tails. And then you write a probability of that event happening on the branch. Now, how would you write the probability of it not being heads? Well, it's similar to the probability of it being heads, but what you do here is you draw this. It's just a dash on top, and this means a probability of it not being heads. And it's also 0.5. You might see your teacher or just online resources using this. This is called complement, but for the advanced higher course spec, the dash is used, so don't use a complement. Now try and do the following questions with the formula provided. The probability of A happening times the probability of B happening is equal to the probability of A and B happening. And here the probability of A happening times the probability of A happening again is equal to the probability of 2A. So how you would do these questions is here. So you want probability of heads and tails happening. That is equal to probability of heads times probability of tails is 0.5 times 0.5, which is 0.25. Now here you want probability of two heads, and that is equal to probability of heads times probability of heads again, which is 0.5 times 0.5, which is 0.25. And then the probability of not getting two heads, you could either write probability of 2H naught or the probability of 2T, whichever one you pair, that they're both right, is equal to probability of T times probability of T, or probability of H naught times probability of H naught, and that is equal to 0.5 times 0.5, 0.25. These were mostly to get you used to the notation and less for the difficulty of the question. With the following information you've learned, try and do the 4 following questions. Question 4 is a bit tricky, but try and problem solve your way through it. So the first thing I would do here is draw two tree diagrams. I can draw two separate ones because these two events are independent. You aren't more likely to get a fizzy drink if you get sandwiches. It's all random. There we are. Now we need to answer questions. So find the probability of a packed lunch containing sandwiches and juice. So we can write that as sandwiches and juice equal to probability of S times probability of J, which thanks to a tree diagram makes it simple to find out. It's 0.5 times 0.3, and that will give us 0.15. Okay, so the next question is, a packed lunch not containing pasta? So the probability of a packed lunch containing pasta is 0.2. So if you just do 1 minus that, we'll get the probability of it not containing pasta, which is 0.8. Same thing here, the probability of a packed lunch not containing juice, the probability of it containing juice is 0.3. So the probability of it not containing juice is 0.7. Now this last one is a bit tricky, but it requires us finding 4 probabilities of 2 events happening. Those events are a packed lunch containing sandwiches and water, a packed lunch containing pasta and water, a packed lunch containing rice and juice, and a packed lunch containing rice and a fizzy drink. So I'll pause the video and quickly get them right now. Okay, so probability of S times probability of W is equal to 0.5 times 0.6, which is 0.3. Now the probability of pasta times the probability of water is equal to 0.2 times 0.6, which is 0.12. Now the probability of rice times the probability of juice is equal to 0.3 times 0.3, which is 0.09. And the probability of rice times the probability of a fizzy drink is 0.3 times 0.1, which is 0.03. Now if we add them all together, we will get the probability of rice or water. This U symbol means or, and we will get 0.54. So the probability of a packed lunch containing either rice or water, but not both, is 0.54. You should also be able to compare theoretical calculated probabilities with experimental ones, and if there's a difference, you should be able to justify why there could be a difference. So let's do the following question. The lunch bag combinations were examined on a random day, and 23% of lunch bags contained sandwiches and juice. Suggest why this is different to a theoretical probability of 15%. Well, to answer these type of questions, you have to either assume a bit or look at the context that you've been given of the question. Now, I didn't give much context in my previous question, but if you would say something like the juice from the day before was left over, so that's why there were more juices, or there was a late delivery of water and fizzy drinks, or the staff working on this particular day had a greater influence on the lunch bag combinations, all of these answers would be correct. You should now be able to understand all of these probability notations apart from this one here. If you don't, then I recommend looking back through the lesson and making sure you've got that fixed, since these will be used in the next lesson. That's now the end of the lesson. Now you should be able to use and understand notation for probability theory. You should be able to calculate probabilities of single and multiple events, and you should be able to calculate the probability of an event not happening.